My face. I know I have a great day. Hey, Dana.
Hello.
Voices are being heard. Absolutely.
It feels very sloppy on their end. All of their lens and everything, so there's great movement. It'll all work out.
I need this 2-week rollout. So the kids coming in on this day by grade level, and then they're all online the week after. And that's, to me, that's very stressful. I'd rather just say, and they're back.
Yeah, I mean, you know, is it a cautious approach, like let's see what happens as we add people?
I don't know, but I would, if they're gonna do it that way, I would just say, okay, we're letting, ninth graders in full time.
Yeah.
We're gonna let 10th graders in full time.
Yeah.
We're gonna let 12th graders in full time, or something like that.
Something like that.
Not
It's a little
just,
complicated.
what?
It's a little more complicated.
No, that's less complicated than paper.
Well, I know, but yeah.
No, or us.
Come on.
No,
But, you know what I mean?
yeah. Right. So, all right.
It looks nice though. I don't know. Hello, second hour. Hello.
Hello.
Nice to see all of you. Hello, second hour at home. Nice to see all of you too. Should I make them say hi? Hey, in 3 seconds, can you guys say, turn your mics on and say hi to me in 3, 2, 1. Hi.
Hi.
Hello.
You know, sometimes my sound doesn't work. Sometimes you guys can't hear me. I can't hear you. And
It's just chaos. So I really like to know that you guys can hear me and I can hear you. And then you guys at home can hear me and I can hear you too. So that's all good. Today, I want to start off with a question from yesterday that I kind of messed up. I messed it up from the get-go. I clicked on the wrong answer. And so if you guys got the right answer, it was wrong and so on. So I'm just gonna go ahead and tell you what the right answer was, show you that question. And I already gave everybody, no matter what you answered for that question, I gave you a point. You guys at home too. So let me show you that question. It wasn't really associated with an EQ, so maybe I messed that up as well. But let me show you that, and I'll tell you what the point was for that entire question. And, you know, I'm glad to admit when I mess things up. Not that. Not that. Where did it go? This. Here it is. So the question had to do with the 30 Years' War. You might remember it was the last slide. My point for that was there is no Germany. There is no absolutist state in this area that becomes Germany. They have this 30 Years' War, devastates the territory. A third of the people died, or a quarter of the people died, or some millions of people died. Anyway, long story short, the correct answer was supposed to be it reduces the population by about a third, and it was so devastating that Germany didn't exist as a unified country until the 1800s. After today, I'm changing that up. I'm going to make it more closely aligned with like no absolutism happened. But anyway, I went through, I gave everybody the point. It's kind of like Oprah, you know, and you win, and you win, and you win. So hopefully that's okay. The rest of the quiz, I think, went pretty well. In fact, this question went pretty well for most people too. But like I said, I messed it up. So I wanted to change that for you. Why don't you at home get ready with your EQs? Why don't you here in class get ready with your EQs? I'm going to talk today about the scientific revolution. That'll take 15, 20 minutes or so. And then I'm going to set you on a web quest. And that web quest will be due on Thursday. It's part of it is on the scientific revolution. Part of it is on the Enlightenment. On Thursday, we'll meet synchronously. So I'll see you guys online for the most part, and you guys at home for the most part. I'll see you here in class. But we'll do the Enlightenment on Thursday, and you'll finish this web quest on Thursday and turn it in.com to me Thursday. So you guys at home, if you have any questions at any point in time, turn your mic on and let me know what your question is. More than happy to answer questions, but hopefully I make things so obvious to you that you get all the EQs that you need. First thing is going to be about geocentric and the heliocentric. Universe is probably wrong, but solar system or geosystem to be sure. Here we go with that. Got a nice colorful scientific revolution. Unit 8, part 4 for you. Yeah. Right. Okay, well, there is a geocentric theory that was made up by the Greeks way, way, way back in Aristotle's time, and it gets kind of updated a little bit after the CE period starts with this guy by the name of Ptolemy. Here's the thought. The thought is that the Earth is at the center of the geosystem, or the Earth is essentially at the center of everything. The heavens, the cosmos, whatever you want to call that, out there, the Earth is at the center of it. And the reason that they believe this is this works for the naked eye. I don't know if you guys have ever spent much time looking up at the sky at night. The stars slowly move across the sky. You know, the moon moves across the sky during the across the sky. It seems like all of those heavenly bodies are stuck in what they call crystalline spheres and are moving around an Earth that is immobile. That's the belief for a long period of time. It works for navigators on ships, and it works, like I said, just people looking at it. And so it's believed for a long period of time. That means you and I know, or we've been told, that the Earth rotates. That means the Earth is stationary and everything is rotating around it. Like I said, it's based on the Greek scientist Aristotle and then Ptolemy. And really what's important for Europe is that the Catholic Church adopts that belief and keeps it.
Hey, Jack. So the Catholic Church is supporting this theory, which means that it's right. It's the truth for hundreds and hundreds of years. I'll come back for Copernicus here in just a second. I think that's something that you have to do with number 12 as well. Number 13 is about the conditions in Europe that allow this scientific revolution to take place. And luckily for us, they go back to the first couple of things that we talked about here in Unit 8. The Renaissance, this rebirth of classical knowledge, of Greek knowledge, might make you think, oh, they're gonna look at Ptolemy again. They're gonna like him so much that they'll just believe what they said. Well, that's true at first, but then these Renaissance men, these guys who want to show off their talents and want to think for themselves and want to, experience and enjoy their wealth, they start to come up with their own ideas about how maybe the old Greek thinkers and maybe the Catholic Church is wrong. So the Renaissance starts this scientific revolution by having people think for themselves. The Protestant Reformation continues that because people start to think the church is wrong about a lot of stuff. If it's wrong about indulgences, if it's wrong about the Pope's power, then maybe it's wrong about its, quote unquote, scientific information as well. So people start to challenge the church, and like I say, the church is in control of all knowledge, so they're going to start to question that. Yeah, we're on 13 right now. So essentially 13 is Renaissance and then also Reformation for those ideas. What we get with this scientific revolution then is new methods of scientific discovery or scientific exploration. Greeks used to just kind of like sit around, maybe look at stuff, and then decide, how things were. Aristotle came up with the idea that matter was made up of 4 different elements, fire and water and air, and fire, water, air, and earth. Thank you very much. You guys are good with your Aristotelian science. And they just observed that sort of and decided that that's the way it was. Now we have people starting to use what I like to call math, observation, and experimentation on our way to, a kind of scientific method. The ability to come up with laws that always seem to work, laws of gravity, laws of planetary motion, laws of inertia. That's what they're looking for, something that always works exactly the same. And they're coming up with this based on some new technologies that are helping them out. For example, if you want to look at the moon, or if you want to look at planets, you might be able to discover actually new moons around other planets. If you look carefully enough, you see a moon go in front of a blip of light that is a planet. There's something there. And so they're using the telescope for things that are far away. They're using a microscope for things that are. They're using various methods of timing things and weighing things. These are all sort of new technologies that are helping them come up with scientific ideas, coming up with laws, and then the printing press, once again, is key for spreading this kind of knowledge. Okay.
What was their first type of measurement for weighing stuff and length?
Scales, I think. So kind of having a balance. And then having a certain weight on one end, and then putting something else on the other end. Sort of, you've seen those scales, those old scales. I like the timing devices they were doing with flowing water sometimes, or flowing sand. The what's it called in English? The hourglass. Yeah. Sorry. Or they had these water glasses too. Filled up with water, and they turn things, kind of let the water flow, and they're able to kind of figure out how long things are taking. Or they use pendulums swinging back and forth to figure out some timing things. It's really pretty neat, all of the things that they're coming up with to do this pretty early on. Back to Copernicus, number 12. Copernicus is a clergyman, as you'll read about when you do the web quest as well. He's Polish, and the church hires him to find out when Easter is. And that's kind of complicated. I don't know when Easter is. I look at the calendar, but it has to be figured out, not on a solar calendar, but on a lunar calendar. And and so Copernicus is looking at the sky a lot. He's looking at the moon a lot. He's trying to figure things out, and he realizes that Ptolemy's ideas don't seem to work out very well. And so he comes up with this theory, just an idea. If instead of having the Earth at the center of everything, if you have the sun at the center of the solar system, then it works a lot better. Things just seem to work better time-wise. You can figure things out easier for that calendar. It's just an idea, and he's a little bit afraid, as you might see when you do the web quest, of publishing this idea, because he doesn't want to get in trouble. He doesn't want to seem stupid. He doesn't want to say anything dumb. So anyway, it's an idea. And he basically dies with that idea just at its very beginning. But somebody else is going to come along. A lot of guys are going to come along, like his ideas, and run with them and prove them. But Copernicus is using, once again, observation, and he's using math to prove a heliocentric theory, that the sun is at the center of stuff, which is really pretty amazing. If you think about it, it means the Earth is rotating, and that everything else, like the stars, not moving. It makes the universe really big, and it's kind of and sorry for the pun, but sort of an earth-shattering idea. A guy who really likes Copernicus's idea and can't keep his mouth shut about them is this Galileo. Galileo is a Renaissance man. He wants to use his brain, his knowledge, to make money, to be famous, to publish things. He's really interested in a lot of different things about the way that the world works. He spends a lot of time experimenting with balls. He rolls balls, he drops balls. He's just really into falling objects and what happens. And if you think about it, maybe you guys did this in science class too. It's kind of cool to experiment. Go to the Leaning Tower of Pisa or whatever and drop two balls off of it. One of them weighs twice or three times as much as the other one. What's going to happen? Or a guy out galloping on horseback. He's got a ball in his hand. He's moving at a pretty good clip. He drops the ball. Does the ball fall straight to the ground, or does the ball kind of curve and go with that former motion of the horse? If you don't experiment and you just make stuff up, you think about it, you're probably going to be wrong. But if you actually do experiment things, you can figure out a lot of stuff. Like Galileo comes up with this law of accelerating bodies, something that Isaac Newton's going to take and improve on a little bit. Galileo also takes this fairly new invention of the telescope, and he uses it to look at all kinds of stuff in the heavens. He looks at the moon, he looks at planets, he even looks at the sun foolishly and kind of burns his eyes out. He's basically blind at the end of his life. Don't do that. There's better ways of doing science. But he observes that the moon is a lot like the Earth in certain places. There's all these rough areas, all these craters, all these canyons and so on. I mean, heck, I can see this with my eye without a telescope. You take a telescope and it really seems that the universe out there is not like what the Greeks thought it was. The Greeks thought that everything out there were these sort of weightless orbs of light made up of a perfect substance called quintessence, a fifth substance. Galileo says, no, I think everything's actually the same throughout the entire universe. And he discovers things like moons of Jupiter. He dispels this notion that everything out there in the heavens is perfect and quintessential. Sadly, though, he lives on the Italian peninsula. And the Catholic Church is really powerful on the Italian peninsula, and he gets in trouble. They tell him to quit. They tell him don't talk about Copernicus, and he just can't help himself. He writes a book about Copernicus, about the heliocentric theory being better than the geocentric theory. And the church comes down on him really hard. They try him for heresy, for believing the wrong things. Not so much about religion, but just challenging the church. He's an old man at this point in time. He's kind of blind. They threaten him with torture. And he's like, what do you want me to do? And they say, we want you to recant. We want you to say that everything that you said about Copernicus being right is wrong. Take it all back, and we'll basically kind of leave you alone. And he says, okay, I'll do that. And he recants, he takes it all back. Sad, because he's right. And the church kind of knows he's right, but the church isn't ready to admit that Copernicus or that Galileo's right. So kind of sad. He lives out his life happily, just under house arrest, instead of being burned to death, which is something that can happen to people who go against the church at this point in time. There's a guy who lives in an Anglican country, the Church of England, and he doesn't have to worry so much about being tried for his beliefs, and this is Sir Isaac Newton. Newton is a weirdo, but he's a genius at the same time. And a little chance to read something about Newton when you do the web quest. But Newton is using Mo. He's using a lot of the ideas that people before him came up with, Copernicus, Galileo, Kepler, Brahe, and so on. And he comes up with 3 laws of motion. Do we know what those are? Do you guys know Newton's laws?
Generally.
Okay. Force.
Something acting on has equal.
Yeah.
Force
Force equals mass times acceleration.
Yeah.
And
Object with the same mass no move unless acted upon with the same force.
All
yeah.
about force.
you guys are good. I'm sure you guys at home know all that stuff too. It's fun too. I know just enough to answer like trivia questions and then I'm done. Well, anyway, Newton also comes up with ideas about how light works and about how vision works. And I got a little anecdote for you, a story about Newton that I don't think is in the web quest. So I'll tell that to you. But he comes up with this law of gravity, or these laws, and he starts to view, and really scientifically minded people start to view the entire solar system and the entire universe as a very intricate clock or machine. Clocks are fairly new at this point in time, and people really like them. They're really into them. And it's like a God clockmaker or watchmaker or machine maker. He made this really complicated thing called the universe. He wound it up, right? It rotates like a clockwork. And he let it go. And for people who are more scientific minded, they figure that this creator isn't super interested in what is going on with the machine after that. That God creates this thing and he just kind of walks away. And so, prayers and clergy people and religious holidays and Pope or no Pope or whatever, that doesn't really seem to be very miracles important anymore. God isn't going to stick his finger in the clockworks to make a miracle happen, is kind of the idea. Now, these guys are still very religious. Newton is really religious. He spends a lot of time trying to figure out the Bible code and figure out when the world's going to end. And he actually comes up with a date that you guys need to be worried about, but I don't, because I'll be dead. It's liberating. I think it's 2067. I'll definitely be dead in 2067, but you guys won't. So be on the lookout for that. I think that this is called deism, by the way, this idea that God is sort of a creator who doesn't really listen too much. So the scientific method, and this is number 15, I guess, it has, they're using Mo in order to gather ideas about science, but they start to think about using rationality, about using your mind, about, experimenting, observing, and so on in other areas too. Challenge previous ideas about the way things should be and come up with new ideas about the way how things could be. So think about politics. We talked about absolutism yesterday. Kings will tell you absolutism is the best way of doing things, but a thinking person might say, no. The king isn't perfect. Maybe the parliament should help him decide how to run the country. So you could get maybe more representative government. Or in terms of religion, a king might say, or a pope might say, one religion is right and the rest of them are wrong. Maybe a thinking person would say, hey, maybe we should tolerate religious minorities. You're not really doing anyone any favors by torturing people over religion or making them believe what you want. Same for crime and punishment. Maybe people should have speedy trials, not be tortured, find out the truth, and then sentence them to something that isn't like horrible torture. Maybe just put them in jail for a little bit. Make the punishment fit the crime. All these kinds of things of education and so on have to do with the Enlightenment, the next thing that we'll talk about. The scientific revolution creates the Enlightenment. People change things for the better using their minds. No longer are people just going to listen to old experts or religious people to decide what's what and what's right and what's wrong. That's it.
Can you hold on to that last one?
I can. That one. So while you guys might be copying that down, I want to tell you a kind of an unusual story about Isaac Newton. Isaac Newton was really interested in the way the eye worked, vision and light. And like I said, he's a bit of a weirdo, a genius weirdo. But apparently, according to the anecdote or the story that I've heard, he takes a knitting needle. He wants to figure out what's behind the eyeball. And he takes a knitting needle and sticks it between his eyeball and his eye socket and kind of moves his eyeball to the side to kind of look and see what's back there. It blinded him for a few days. Don't stick knitting needles in your eyeballs or your eye socket. It is really not good for you. Just for a few days, yeah. It's worth it. It's worth putting up with that for a few days just to see what's back there. Don't do that.
Did you find anything?
I don't think so. I don't think you can see the optic nerve unless you blind yourself permanently. But good. He's really into his science. He's very committed to that. All right. I'm going to go back to this. Oh, I shouldn't have stopped sharing. It's okay. Back to you guys. Hi, everybody. Here's what I'd like you to do, or here's what we're doing here in class, and then you guys can decide if you want to do this or not. But once again, I'm going to present. If you go to Schoology, and actually all of you here, could you pop open your devices? You guys at home already have your devices open. But go to Schoology, and at the bottom of Schoology, as usual, we have the Scientific Revolution and Enlightenment web quest that I would like you to look at. Not to turn it in, but this bit right here. Make a copy of this. It's a Google Doc. Nice. And then we can have a look at a little bit of info about Copernicus and answer some questions. There's some info about Galileo and some info about Newton. My advice to you is that you finish this science part today. On Monday, no assignment particular tomorrow. On Thursday, I'll talk about the Enlightenment, and then on Thursday you could finish the Enlightenment, because this whole thing, and the Enlightenment is this bit right here, but this whole thing is going to be due, and you're going to turn it in.com to me on Thursday. If you want to finish it early and turn it in early, that's fine too, but hopefully that works out nicely, where this takes the rest of your time today to do the science bit, and then after my 15 to 20 minute lecture on Thursday, you finish the rest with the rest of your time. You guys at home have any questions? No? Okay. Well, good. You guys at home can leave if you want to, and work on that, or do whatever you need to do. And I will see many of you on Thursday. And I'll be looking forward to your web quest on Thursday as well. Have a great day.
Thank you.
Bye.
Thank
Thank you, bye.
Thanks. Who's in the kitchen getting a snack? I would just do part one, yeah. I think time-wise it works out if you finish that today and then do part two after I talk about the Enlightenment. And I'll mark who's here, who's not here today. Sophia and Ellen, I'm gonna go. I'll see you later.